You ever stop and wonder how, when you hit a key on your keyboard, the letter just pops up on the screen? Or how a digital clock knows exactly which little lights to turn on to show the time? Well, it turns out there are these secret translators working behind the scenes, and today, we're going to pull back the curtain on them. We're talking about encoders and decoders, the absolute workhorses of our digital world.
All right, let's kick things off with a little thought experiment. Picture a basic calculator, the one sitting in your drawer. Deep inside, it's all just ones and zeros, right? A stream of binary code. So how does that string of ones and zeros become a big, bright number 8 on the display? What's the magic trick? Well, it's not magic at all. It's a really clever little circuit, basically a tiny electronic translator.
So let's meet the first piece of this puzzle. This is all about decoding our digital world, and we're going to call our first hero the light switch operator. And here's why. Imagine you're in a massive room with, say, 100 light bulbs, but you've only got a handful of switches. A decoder is kind of like a super smart operator who can take a secret code from those few switches and know exactly which single light bulb to flip on. It's pretty cool.
Okay, let's get just a little bit technical for a second. A decoder is what's called a combinational circuit. Basically, it takes a small number of input lines, let's call that number n, and it translates them into a huge number of output lines, specifically up to 2 to the power of n. So think about that. If you have just 2 input lines, you can control 4 different outputs. 3 inputs, bam, you can control 8 outputs. But here's the golden rule, the most important part. Only one of those outputs is ever turned on at the same time. So what's its main job, really? At its heart, a decoder takes a tiny little binary code and picks one specific thing to activate. That's it. So you can really just think of it as an expander. It takes a small, coded instruction and expands it into a single, clear action.
All right, so how does this actually work in practice? Let's look at a super common example to make it really click, the 2 to 4 decoder. Just like the name says, it's going to take 2 input lines and use them to manage 4 separate output lines. And this right here, this is the decoder's cheat sheet. It's called a truth table. It shows every possible outcome. So look, if both inputs, A and B, are 0, what happens? Boom, only the first output, Y0, gets switched on. Now, what if the input is 0 and 1? Well, then Y1 lights up and all the others stay off. You see the pattern. Every single unique input combo triggers one and only one output.
So how does the circuit know what to do? It's not magic, it's logic. It follows these little rules called Boolean expressions. Now don't worry, you don't need to be a math whiz for this. The main takeaway is that each of these little equations is crafted to be true for only one specific input. That's the secret sauce that guarantees only the right output wire gets the juice.
And listen, this isn't just some abstract concept from a textbook. Decoders are literally everywhere. You know your computer's memory, the RAM. It uses decoders to find the exact microscopic spot to store or retrieve data. That digital clock on your microwave, there's a decoder inside turning a binary code into the numbers you see. They are the unsung heroes, silently working away, selecting and activating things in pretty much every piece of tech you own. Okay, so that explains how a device can take a code and do something with it. But wait a second, that kind of brings up a new question, doesn't it? Where did that neat little binary code come from in the first place? How did something like you pressing a key on your keyboard get squished down into a simple code for the decoder to even read?
Well, that leads us perfectly to the second hero of our story, the encoder. It's the reverse mission. If the decoder is our light switch operator, then the encoder is the shorthand expert. It sees a single big event, like you pressing the Q key, and its whole job is to quickly jot that down into a short, efficient code.
And you probably guessed it, but yeah, it's the exact opposite of a decoder. An encoder takes a whole bunch of input lines, again up to 2 to the power of n, and squishes them down into just a few n output lines. Its entire purpose in life is compression. It takes lots of potential inputs and turns them into one simple, compact binary code.
And we can see how this works with its own truth table. This is for a 4 to 2 encoder. Look here, if the first input, D0, is active, the output code is 00. If the next one, D1, gets a signal, the output becomes 01. See? Each individual input line gets its own unique binary fingerprint on the output. But, there's a problem here, a practical one. This simple encoder we're looking at has a big assumption that only one button is ever pushed at a time. So, what happens when you're typing fast and you accidentally mash 2 keys at once?
A basic encoder would just freak out. It would know what to do and would probably just spit out nonsense. And that's where engineers got clever and came up with the priority encoder. You can think of it as the smarter, upgraded version. It has a built-in ranking system, so if two keys get pressed, it's programmed to say, okay, I see both of you, but this one has a higher priority, so I'm only going to listen to it. It just ignores the rest. This is the simple but brilliant trick that lets things like keyboards work flawlessly. So where do these guys live? Well, the most obvious place is your keyboard, right? Every single key you press is being turned into a binary code by an encoder. But they're also absolutely critical for things like data compression. They help shrink down big files so we can send them over the internet, making everything from streaming video to sending an email way, way more efficient. All right, we've met our two main characters. So now let's have a little fun with an encoder versus decoder showdown. We'll put them head to head so their differences are crystal clear. So here it is, the tail of the tape. You can see they're perfect opposites. The function is completely reversed. One is all about compression, the other is all about expansion. You could say an encoder is used for creating a code, while a decoder is used for understanding and acting on that code. They really are just two sides of the same digital coin. Look, if you're going to walk away remembering just one thing from all this, let it be this right here. An encoder compresses. A decoder expands. That's it. One squishes information down, the other opens it back up. It's that simple. Okay, let's zoom all the way out now and look at the big picture. Your world translated. Because here's why this really matters. This dance of encoding and decoding, it's happening constantly. Billions, maybe trillions of times a second, inside pretty much every single piece of technology you own. Really, what they are is the fundamental language of our digital world. They're the universal translators. They take a human action, like you clicking a mouse, encode it into a language the machine understands, and then the machine uses a decoder to translate that language back into an action, like opening a file. It's a constant conversation. And this whole process is happening right now, this very second, just so you can watch this. So, I'll leave you with a final thought. Now that you know about these secret little translators working tirelessly inside your tech, what's one thing you use every single day that you now realize would be completely useless without them? Give it some thought. You might be surprised.